So this video is for integrated 3. This is the chapter 3 classwork, number 5 and number 7. So we did some of this in class today. I'm just going to speak about these just to make sure everyone understands. When you are solving absolute value equation problems, which is what the first problem is, you want to isolate your absolute value. That is what you want to do. And when you isolate your absolute value, you want to look at the number that you get on the other side. So when I say isolate, I mean this whole absolute value of 8x minus 2 needs to be by itself. So I am going to get rid of the 4 by dividing this side by 4 and dividing this side by 4. And when I do, I'm going to get the absolute value of 8x minus 2 is equal to 2. Once you do that, what you want to do is you want to look on the other side of the equal to see what type of number this is. This number has to be positive, okay? Because when I take the absolute value of 2, for example, I would get 2. When I would take the absolute value of a negative 2, I would also get 2. So anytime I take the absolute value of a number, it is the positive distance that it is to 0. So 2 is 2 away from 0, and negative 2 is 2 away from 0. So this inside right here, this 8x minus 2 could be equal to 2, or it could have been equal to a negative 2. So those are going to be the two equations that we're going to work out. So now I am going to work out 8x minus 2 is equal to 2. And then 8x minus 2 is equal to a negative 2. And I'm going to solve both of these equations. So this one's going to be 8x is equal to 4. So x is equal to 4 over 8 or 1/2 if I reduce. The second equation, I'm going to add 2 to both sides and I end up with 0. And when I divide by 8, I get x equals 0. And those are our two answers. So usually for absolute value, you're going to get two answers. On B, this problem is a square root. So just like with our absolute value, we are also going to isolate the square root. So I want to get this square root of 4x minus 8 by itself. First thing I'm going to do, minus 9. Then we're going to get 3 times the square root of 4x minus 8 is equal to 6. Still trying to isolate that square root. So the next thing I'm going to do is I'm going to divide by the 3. And when I do, this 3 and this 3 make a 1. And I'm going to be left with the square root of 4x minus 8 is equal to 2. Now, when we are doing these square root problems, we are looking at what we consider the principal root. So here, when I have a square root, okay, I am looking at the principal root, which is always positive. Okay, so principal root is always the positive root. Because when I take the square root of something, I get two answers, a positive and a negative. But when they draw the square root for you, they are telling you that they want the positive one unless they have a minus in front. So they want the positive one. So at this point, I would always want to make sure that this number here is a positive. If it wasn't, I would have no solution. Similar idea would have happened over here. When I take the absolute value of the quantity 8x minus 2, and this number here has to be positive, has to be positive. If it's not a positive, and it happened to be like a negative 2 that was outside of this absolute value that I needed it to equal, it would be no solution. So over here, I check it is a positive, so now I can work it out. So to undo a square root, I'm going to do the opposite, which is squaring. So I'm going to square this side and I'm going to square this side. And when I do, I'm going to get 4x minus 8 is equal to 4. And then we solve. We get 4x is equal to 12. We divide by 4 and we get x is equal to 3. So on letter C, I have to multiply out these two binomials. So there's two ways to do it. One way is to do an area model where I am going to multiply those out. And so I am going to have a 2y minus 3 times a y minus 2. And I am going to get a 2y squared minus 3y minus 4y plus 6. So that means I have a 2y squared minus 7y plus 6 is equal to a negative 12y plus 18. Another way is you could have done FOIL, first, outer, inner, last. First, outer, inner, last. I'm really just double distributing. That would give me the same result. Okay. Now, at this point, I have a quadratic because of that y squared. So I want to get everything on one side and 0 on this side. So I need to get rid of that negative 12y and that 18. So I am going to add 12y to both sides. I'm going to minus 18 from both sides. And I am going to end up with a 2y squared plus 5y minus 12 is equal to 0. Then I can factor this. So I'm going to do a box to diamond. I'm going to do the box up here. And then let me do the diamond here. So I am going to have a 2y squared and a negative 12. Those two multiply to a negative 24y squared. So I'm going to put a negative 24y squared. And it has to add to that 5y. So I'm going to put a 5y here. So what multiplies to a negative 24y squared and adds to a 5y? That is going to be an 8y and a negative 3y. An 8y and a negative 3y. So now I want to try to find the outside. First thing I'm going to do is figure out how did I get that 2y squared? And how I got it was I took a 2y times a y. This is now going to be a plus 4. This is now going to be a negative 3. So my factors are going to be 2y minus 3 times y plus 4 is equal to 0. And then I set both of these parentheses to 0. When I do here, I'm going to get a 3/2. When I set this to 0 and work it out, I get a negative 4. And those are our two answers. Okay, on letter D. On D, different ways to do it, but I personally would fraction this. I want to multiply by something that's going to get rid of an x, a 3x, and a 3. And what that is going to be is to multiply by 3x. So I'm going to go 3x times 5 over x plus 3x times 1 over 3x. And then 3x times 4x over 3. Now, hopefully, each one of these denominators, the x, the 3x, and the 3 will cancel with that 3x. So x goes into 3x, and I'm left with 3, so I get a 15. 3x cancels with 3x, and I get a 1. 3 cancels with 3, and I get a 4x squared. So now I have 16 is equal to 4x squared. I'm going to divide by 4. 4 is equal to x squared. And then I need to take the square root. When I take the square root, instead of them drawing the square root for us like they did in B, that is where they want the positive, the principal root. Here, they want every possible solution. So when I take the square root of this and the square root of this, the square root of a 4 is going to be a positive and a negative 2. And then the square root of x squared is x. So I get two answers, 2 and negative 2. Now on letter E is an absolute value. You want to get it isolated. It is. It's all by itself. But then we want to look at the other side. And remember, when we take the absolute value of something, it has to equal a positive. So since this is a negative, an absolute value cannot equal a negative result. Okay, so just so you understand, if I was to have taken the absolute value of 6, I would have gotten 6. If I took the absolute value of a negative 6, I also get 6. Because on a number line, if I have 0 and I have negative 6 and 6, how far am I from 0? I'm 6 away. I'm 6 away. It's always going to be a positive result. So there's no way to get this negative. So our answer is going to be no solution. Okay. You always want to get your absolute value by itself. If when you get it by itself, you end up getting a negative on the other side, no solution. Okay, on F, let me just get rid of that. Okay, so on this one, I'm going to do a similar idea to the one I had before with fractions. I'm going to fraction bus. I'm going to multiply everything by 15. So I'm going to go 15 times 6w minus 1 over 5 minus 15 times 3w equals 15 times the 12w minus 16 over 15. And again, hopefully our denominator will cancel out. 5 goes into 15 3 times. So I have a 3 times 6w minus 1. I'm going to distribute the 3 to both of them. Here, this doesn't have a denominator, so I'm actually going to multiply that out. No denominator cancels, and I get a 45w. On the other side, this 15 and 15 cancels, and I get a 12w minus 16. And then we have this to solve. So this is going to be an 18w minus 3 minus 45w is equal to 12w minus 16. I am going to combine like terms on the same side of the equal. And when I do, I have an 18w that's going to minus with a 45w, and I'm going to end up with a negative 27w minus 3. At this point, I would add 27w to both sides. And I'm going to get a negative 3 is equal to 39w minus 16. I'm going to add 16 to both sides, which is going to give me a 13 is equal to 39w. I'm going to divide by the 39. And when I have 13 over 39, that really can reduce to 1 over 3. And that is my w. I get 1 over 3. Okay. On the next problem, This one is a quadratic, but what I'm going to do is when I have that quantity with the x being raised to the second power, let's isolate that. So I'm going to add 2 to both sides. I get x minus 3 squared minus 2 equals, sorry, I added the 2 to both sides. So those 2's canceled out. And I'm going to get a negative 3. Now I'm going to undo the square by square rooting. So when I square root, I'm going to get an x minus 3 equals a positive and negative. And when I take the square root of a negative number, that's imaginary. So it's going to be I root 3. Okay, the root 3 cannot be simplified at all, but the negative underneath the radical becomes an I, so that comes out. Then I'm going to add 3 to both sides, and I get 3 plus or minus I root 3. And that is our answer. On H, for this one, this is kind of a new one for us. But what I want you to notice is we have this x plus 2 being squared times 4 times this x plus 2. So you'll notice that in both of those highlights, I have an x plus 2. So one way to do this problem is to define another variable. Let's say, our book usually uses u. So let's say I let u equal x plus 2. So everywhere I see an x plus 2, I'm going to write a u. Everywhere I see an x plus 2, I'm going to write a u. So this is going to become u squared plus 4u minus 5 equals 0. This is called rewriting it in a simplified form. Okay. So now I'm going to factor that. That's just going to be a diamond. What multiplies to negative 5 and adds to 4? That's going to be a positive 5 and a negative 1. So this is going to be u plus 5, and u minus 1 equals 0. So I'm going to get u is equal to a negative 5, and I'm going to get u is equal to 1. Now, there was no u in the original problem if you're looking at it. Remember, we made u represent an x plus 2. So in place of the u, I'm going to write x plus 2. In place of this u, I'm going to write x plus 2. This is trying to rewrite this problem in a form that is quadratic in nature. Okay, it's like a quadratic. This one actually is a quadratic, but some of them will not be quadratics, but they follow the same principle when you see it in this form. So I'm going to solve these two equations. This one, I'm going to minus 2 from both sides and get a negative 7. The other one, I'm going to minus 2 from both sides and get a negative 1, and those are our two answers. So in the original problem, I noticed that we had a x plus 2 here and an x plus 2 here. So I said, let u be the same as x plus 2. And I put a u everywhere there had been an x plus 2. And I ended up with a quadratic to solve. We'll talk more about this on Monday, but you can copy this down so you have this as an example on your paper. Okay, so these ones here are a little more complicated, but hopefully after that last problem, maybe you notice, hey, there's an m squared plus 5m minus 24, and another m squared plus 5m minus 24. So what I'm going to do is in place of that, okay, in place of m squared plus 5m minus 24, I'm going to write a u in place of the whole thing. So instead of this being m squared plus 5m minus 24, since m squared plus 5m minus 24 is the same as u, I am going to write u squared minus, and again here, this is the same thing. So in place of those, I'm going to write u equal 6. Now I have a quadratic. I am going to get this to be equal to 0. I am going to minus 6 from both sides, and I'm going to factor. So this is a diamond. What multiplies to negative 6 and adds to negative 1? A negative 3 and a positive 2. So I'm going to get a u minus 3, and a u plus 2 is equal to 0. When I solve for this, I get u is equal to 3. When I solve for this, I get u is equal to negative 2. Which would be nice if I had a u in my problem, but I did not. Remember, there was an m squared plus 5m minus 24, not a u. So what I'm going to do is I am going to rewrite in place of the u, m squared plus 5m minus 24. So I'm going to have m squared minus plus 5m minus 24 equals 3. I'm going to have m squared plus 5m minus 24 equals a negative 2. And these are two quadratics. Remember I said we need to know how to solve quadratics because most of our problems down the road are going to end up being quadratics. Here it is. Okay, we've got quadratics everywhere on this problem. So I'm going to minus 3, and I'm going to get m squared plus 5m minus 27 is equal to 0. For this one, I'm going to get m squared plus 5m. When I add 2, I am going to end up getting a negative 22 equal 0. Then we are going to solve these. So they look like a diamond. If you can think of something that multiplies to a negative 27 and adds to a 5. The only things I can think of that multiply to 27, 1 and 27, 3 and 9. Neither one of those are going to give me a 5. So I'm going to have to use quadratic formula. Here for a negative 22, I'm going to have a 1 and a 22. One of them's positive, one of them's negative. A 2 and 11, neither one of them are going to subtract and give me a 5. So I have to use quadratic formula. So I'm going to do the quadratic formula twice. So let me just jot down the quadratic formula real quick. Okay, I'm going to move this over for a sec. And here, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and that's when you're solving ax squared plus bx plus c, and this is the key, equal 0. We have that format. Okay. So this one here, let me solve this one in blue. Okay. So over here, I'm going to have x equal, my b is a 5, so this is going to be a negative 5 plus or minus the square root of b squared, so 5 squared, which is 25, minus 4 times my a, which is 1, and my c, which is a negative 27. All over 2 times my a, which is 1. So for this, I'm going to get negative 5 plus or minus the square root. And what I'm going to do is I'm just going to do that math underneath the square root. I'm not going to actually type the square root. I'm just doing the math underneath. So let me grab Desmos real quick. So again, I'm doing the 25 minus 4 times 1 times negative 27. So 25 minus 4 times 1 times a negative 27. And I get a 133 as my answer. Okay. Let me just make this a little bolder. Okay. So this was a 133 over 2. That's going to be my answer. That is one answer. It's not pretty, but that's my answer. Then I'm going to do the same. Let me just move this over with my m squared plus 5m minus 22. So let me do that in this teal color. Okay. So I'm going to be solving that here. So again, I'm going to have x is equal to negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times my a, which is 1, and my c, which is a negative 22, all over 2 times 1. Okay, so I'm going to have a negative 5 plus or minus, and let me do, again, the square root. What's underneath the square root, I should say. So let me move this over here for a sec, and let me clear. Okay, so I'm going to have 25 minus 4 times 1 times a negative 22, and I get a 113. Okay, so I'm going to have the square root of 113 all over 2. And that's our second answer. Okay, so this is where I'm trying to get you guys to understand that it's really important that we know how to solve a quadratic by factoring like I did in red, or quadratic formula like I did in blue and teal here, because sometimes we have to do more than one thing. Okay, let's take a look at B. And again, I'm not expecting us to master this. I want us to get it on our paper, process it. We're going to practice more on Monday. Okay. B. For this, you need to understand a little bit about laws of exponents from integrated 1. So when I have x to the a raised to the power b, power to power, we multiply the exponents. Why am I saying that? So what we notice here is we have an x to the 1/3 and we have an x to the 2/3. What I'm going to do here is I am going to let u equal x to the 1/3, which is this right here. Okay. I'd rather have a u there than an x to the 1/3. Then what I'm going to end up doing, let me just copy this. So I can just copy the blue here. Don't need that circle. Okay, so what I'm going to do is I'm going to take this u to the 1/3 and I am going to square both sides. I am going to square this and I'm going to square this. When I do, I'm going to get a u squared. And when I have power to power, I multiply. So here, power to power, I multiply. And I'm going to end up with x to the 2/3. So now, hopefully what you'll notice is this is x to the 2/3. So now, in place of x to the 2/3, I can write u squared. So I'm going to write u squared minus, And my x to the 1/3, which is here, remember I'm going to have be a u. So I'm going to write minus u minus 56 equals 0. This is a much nicer problem than having it be x to the 2/3, x to the 1/3. I'm going to have to deal with them, but I'll deal with them at the end. So this is one I can just do a diamond. So for a diamond, let me just do it above here. What multiplies to negative 56 and adds to a -1? Well, that's going to be a -8 and a 7. So this is going to be a u minus 8 and a u plus 7 is equal to 0. I solve the first parenthesis and I get u equal 8. I solve the second parenthesis. Again, I'm always trying to make these 0, and that means u has to be a -7. I would be done if my problem was u squared minus u minus 56. It wasn't. Remember, up here, this was my problem. Okay, that is what I need to solve. That has x's. So what does u equal? Remember, u is the same as x to the 1/3. So I am going to rewrite this as x to the 1/3 is equal to 8, and x to the 1/3 is equal to -7. Now, I don't want it to be a 1/3. Okay, you might remember from integrated, hopefully you remember from integrated 2, that if I raise something to the 1/3, that is really the cube root. I'm really taking the cube root. So I'm going to cube both sides to undo a cube root. Another way to think about it is I want x to the 1, not x to the 1/3. So what could I raise x to the 1/3 by to get x to the first? Remember, power to power, we multiply. So I'm going to raise it to the reciprocal, 3. So now when I work this out, x to the 1/3 raised to the third is really just x to the first, or x. And then let me put 8 to the third in my calculator, and I get a 512. That is going to be one answer. For the other one, I am also going to raise both sides to the third. Okay, I'm raising it to the reciprocal, or thinking of it as a 1/3. So that's a cube root. So to undo a cube root, I cube. Okay, so this is going to be x is equal to, and a -7 raised to the third is a -343. And those are our two answers. Again, get this down on your paper. See if you can follow the process. We're going to practice these in class again on Monday. Problems like it, not the same ones. Okay, on C. Okay, so on a problem like this, we have this y to the third, and then we have this y to the sixth. Okay, that's what I'm like kind of concerned with. So what I'm going to do is I'm going to take this y to the third, and I'm again going to let it equal u. Let it equal u. And you might say, great, but the other one's a y to the sixth. Yes, it is. But if I was to take u equal y to the third, okay, which I decided to make this a u, okay, then what I'm going to do is I am going to cube both sides. So I am going to cube this side, not cube, sorry, square. I apologize, square. And I'm going to square this side. And you might say, well, why are you squaring? Because quadratics have a square and then just the variable. That's always how they are. Right now, this is not just a variable, and this is not just a square. But if I make this be u, will this be u squared? So I took u equal y to the third. I squared both sides, and I'm going to get a u squared, and power to power I multiply, and I get a y to the sixth. So I am going to put u squared in place of my y to the sixth because of this. I am going to put a 3u where u is going in place of my y cubed because I defined u as y cubed. And then I get this problem. So what you want to start noticing is that if your middle term is squared, not the 3, but the y cubed, if you get this one, then it's quadratic in nature. Okay, let me just write that out. Quadratic in nature. It is not a quadratic because a quadratic is not a y to the sixth, it's a y squared or an x squared, or in this case, a u squared when I rewrite it. But I can force it into a quadratic. So now I'm going to solve this. This is just a plain diamond. What multiplies to negative 18 and adds to 3? A positive 6 and a negative 3. So my factors are going to be u plus 6. I get a really simple problem at this point. U minus 3 equals 0. I solve the first parenthesis. What makes that 0? A negative 6. What makes the second parenthesis a 0? A positive 3, which would be great if we had u in our problem. We did not. Remember, u was the same as y to the third. So this is going to be a y to the third is equal to negative 6. And let me just move this over here. A y to the third is equal to 3. So how do we solve those? Well, to solve those, you cube root. I cube root this, I get a u. I mean a y. I apologize, wrong letter. I cube root the next one, I get the cube root of a negative 6. That's your answer. When I have a y cubed equal 3, again, I cube root it. I get y. And when I take the cube root of 3, I get the cube root of 3. Those are our answers. On D. Again, for this one, notice that this is a square root of p. I want to look and see if that is helpful to get p. What I'm really looking for is, can I have u represent the square root of p? Okay, so this becomes a negative 12u instead of the square root of p. But I can only do that if, when I square both sides, I end up getting p. And when I square this side, I get u squared. And when I square a square root, I do get p. So this is going to really be a u squared minus 12u is equal to a negative 35. I want to get 0 on this side, so I'm going to add 35 to both sides. Again, quadratics, quadratics, quadratics. When I work this out, what multiplies to a positive 35 and adds to a negative 12? A negative 7 and a negative 5. So I'm going to get a u minus 7 and a u minus 5 is equal to 0. So I get u is 7. Oops, I'm boxing around. I wish that was my answer. And u is 5. But we did not have a u. What did u represent? U represented the square root of p. So in place of that and in place of that, I'm going to write the square root of p. So I'm going to have the square root of p is equal to 7. Okay, which is okay to have a positive 7 on the other side. If that was a negative 7, I'd be done, no solution. On this one, the square root of p is equal to 5. Again, that's okay. I can have a principal root equal a positive 5. Now I need to square both sides. Okay, when I square this, I get p. When I square this, I get 49. When I square this, I get p. When I square this, I get 25. These are our two answers. E. On a problem like this, couple things you want to understand. First off, we do not like having this as an exponent. Okay, and notice that I also have it here, but it's squared. So what I'm going to do is I'm going to, again, let u equal the square root of x plus 1/4. So I'm going to rewrite this as 3 to the u, and on the other side, 9, and that's going to be a u squared because of the square right there. So this is where you have to remember, again, integrated 1. When you have a base to a power equals a base to the power, you want to get the bases to be the same. Recall that a 3 squared is equal to a 9. So I can rewrite this 9 as a 3 squared. So I'm going to keep this as a 3u to the power u. This 9, let me do it in this color. This 9 is really going to be rewritten as a 3 squared. So I'm going to rewrite the 9 as a 3 squared. And that 9 is really raised to the u squared. So again, we see that we have power to power. When we have a base raised to a power, and that's raised to another power, power to power, you multiply. So this is going to be a 3u is equal to 3 to the 2u squared. And when we have 3 to a power equal 3 to the power, you can set the exponents equal, and we're going to solve that. So I'm going to go u is equal to 2u squared. It is a quadratic. I have a u squared and a u. I need to get everything on one side, 0 on the other. So I'm going to rewrite this as 0 is equal to 2u squared minus u. And I'm going to factor. I'm not going to do a box. I'm not going to do a diamond. I just noticed that, hey, in both of these, I can take out a u. And I'm going to be left with a 2u minus 1. We have to remember how to factor. So I'm going to get u equals 0 as one answer. And when I set this one to 0, it is going to end up being a positive 1/2. Almost done. Did not have a u. Okay, don't lose track of what we're actually trying to do. We're trying to solve for x. And u is really this. Okay, so in place of that u, I'm going to put the square root of x plus 1/4. In place of that, I'm going to put the square root of x plus 1/4. So I'm going to rewrite this as the square root of x plus 1/4 is equal to 0. And the square root of x plus 1/4 is equal to 1/2. And we solve here. I need to undo the square root. So I square both sides and I get x to the 1/4 is equal to, let me just make sure everyone understands, I'm squaring this, I'm squaring this. Okay, that's what I did. And when I do, this is going to be a 0. So one answer is going to be a negative 1/4. That's one answer. On the other one, when I square this side and square this whole side, that whole quantity, that whole fraction, I am going to get a x to the 1/4 is equal to 1/4. I'm going to minus 1/4 from both sides and I get 0. Those are our two answers. Okay, again, I want us to get this down so we have this. I'm going to make a copy of this for us to put in our composition book as notes. We're going to practice on Monday.